The two-stage Falcon 9 vehicle with the payload fairing is 70 meters or 229 feet tall. When fully loaded, it will hold just over 1 million pounds of propellant, which the vehicle will burn through in less than 3 minutes after liftoff. At launch, Falcon 9 produces more than 1.7 million pounds of thrust, and rockets like Falcon 9 don't use all that power just to go straight up. Early in flight, Falcon 9 will perform a gravity turn, a smooth pitch maneuver that tilts the rocket sideways to build up horizontal velocity. You may hear this call-out about 10 seconds into launch as vehicle pitching downrange. Once the first stage completes its portion of the mission, it will shut down and separate. A staged rocket like Falcon 9 sheds the booster so that Stage 2 and the payload can keep climbing faster and more efficiently. At the bottom of the first stage are 9 Merlin engines that propel Falcon 9 off the ground and up to the thinner parts of Earth's atmosphere. The first stage is designed to be reflown with minimal refurbishment between flights. Due to the additional performance required to deliver today's payload to orbit, this will be the 22nd and final flight for the first stage booster supporting this mission. This booster first launched on November 26, 2022, and has since then logged 1,062 days in service. Over the course of its career, it has launched 3 times from Space Launch Complex 39A at Kennedy Space Center, and today will be its 19th launch from Space Launch Complex 40 at Cape Canaveral Space Force Station. It has returned from orbit to Earth 21 times, landing on a drone ship in the ocean 18 times, and on land 3 times. Our payload today, SpainSat NG II, is safely enclosed inside of the 17-foot diameter payload fairing, which is the structure at the very top of the rocket. Made of a carbon composite material, the 2 sides of the fairing form a clamshell around the satellite to protect it during ascent. The fairing halves are then separated at about 3.5 minutes into flight, after which they will parachute back to Earth. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again. The fairing halves supporting today's mission are flight-proven, with one half flying for its 28th time and the other flying for its 16th time. Below the fairing, we have the second stage, which is the part of the rocket that will take the payload to space today. The second stage will ignite its single Merlin vacuum engine, or MVAC for short, about 2 minutes and 48 seconds into flight, and will then relight for a second time before we deploy the satellite. With its extended nozzle and optimized design, the MVAC drives maximum performance in the vacuum of space. The launch tower's strongback is now beginning to move away from Falcon 9, allowing it to stand freely before liftoff. The TE has 2 components, a strongback alongside Falcon 9 and a launch mount underneath. The launch mount has 4 hold downs that release at T0. The strongback is hinged to that launch mount and is rotating about 2 degrees away from Falcon 9. At liftoff, the strongback will move 45 degrees away to clear the way for Falcon 9's launch. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. The first stage and second stage should finish loading liquid oxygen.
Stage 1 LOX load is complete.
And there you just heard, the first stage has finished LOX loading. Liquid oxygen loading for the first stage is the final propellant load for the booster. The tanks are also pressurized using helium, which is chilled so that it stays compatible with the cryogenic plumbing. During flight, that pressurization helps force propellant into the engines as the tanks empty. At T-minus 60 seconds, Falcon 9 will enter startup. At that point, the rocket's onboard flight computers will take over, and from there on out, the countdown will be fully autonomous. Just inside of T-minus 2 seconds, the 9 Merlin 1D engines will ignite, and once they're at full power, Falcon 9 will lift off the pad and begin its climb to orbit. After that engine start, the Falcon vehicles are held down until all vehicle systems are verified as functioning normally before we release for liftoff.
Falcon 9 is in startup.
As you just heard, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 are pressurizing for launch.
Go for launch.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Falcon, go SpainSat NG II.
Vehicle is pitching downrange.
M1D chamber pressure is nominal.
As you can see, Falcon 9 has lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The Falcon flight computer will now begin throttling down engines in preparation for max Q, or maximum aerodynamic pressure.
Power and telemetry nominal.
Good call out there for a nominal state of the vehicle.
Vehicle is supersonic. Max Q.
As you just heard, we've just passed through max Q. Again, that is the maximum aerodynamic pressure the vehicle will experience. In order to achieve orbit and avoid being pulled back to Earth, the Falcon 9 rocket needs to reach a velocity of roughly 17,500 miles per hour horizontally. To assist with this, the first stage performs a gravity turn, initiated by a pitch-over maneuver just 10 seconds into flight. This is also the engines gimbal a small amount for about 5 seconds, slowly turning the first stage into an angled trajectory. This angled trajectory combined with gravity's pull will place the rocket into the final horizontal flight path. You can track our progress to orbit by keeping an eye on the first and second stage telemetry in the bottom corners of your display. Now we are going to have several events coming up in quick succession, starting with main engine cutoff, or MECO, when we shut down the 9 Merlin 1D engines on the first stage. Following that, the first and second stages will separate. Following that, we'll have the first ignition of the MVAC engine, also known as SES-1. SES-1 will shortly be followed by fairing separation.
Stage separation confirmed.
Main engine cutoff. MVAC startup.
And there you heard and saw those events that happened back to back: MECO, stage sep, and SES-1. As a reminder, the first stage will not be recovered today. In preparation for this, we removed the landing legs and grid fins to decrease the mass of the first stage and save them for use on future missions. But for now, we say to the first stage, thank you and farewell. Fairing separation is next in just a few seconds. We will be attempting to retrieve both fairing halves once they fall back to Earth using our recovery vessel, Doug.
Fairing separation confirmed.
And as you just heard, fairing separation has been confirmed. These fairings will orient themselves with gas thrusters for entry into the atmosphere. As they near the ocean, each fairing half will use a gas-powered deployer to release a parachute. The fairing computer will send commands that steer the fairing to the ocean landing, where Doug will attempt to recover them. With that confirmation, we have a few minutes between our next major milestone event, SECO-1, when we'll shut down our MVAC engine on the second stage. After that, we're going to look for confirmation of good orbital insertion. The MVAC engine is optimized to operate in space, producing...
Stage 2 FTS has safed.
There you just heard that our Stage 2 FTS has safed. As I was saying, the MVAC engine is optimized to operate in space, producing 220,550 pounds of thrust in vacuum, and is designed to be stopped and restarted multiple times.
MVAC shutdown.
And there you heard the call out for second engine cutoff, or SECO-2, as MVAC shutdown. We're now awaiting confirmation of nominal orbital insertion.
Nominal orbit insertion.
And we have confirmation of nominal orbital insertion. The second stage is now embarking on its coast phase. After the coast phase, we will light that MVAC engine for a second time, just before the T plus 27 minute mark, and that will be followed by payload deploy around the T plus 34 minute mark.
MVAC startup.
And as you just heard, our Merlin engineering team has confirmed that we have power on the second stage engine. This burn will last approximately 67 seconds, typical for a geostationary transfer mission. If you watch the speed gauge on your screen, you'll see us adding over 2,500 meters per second to the velocity of the second stage and the SpainSat NG II payload. Maximum acceleration during this burn will reach 4.8 Gs as the remaining propellant is burned off. Today's satellite will be placed into a geostationary position at 30 degrees west. SpainSat NG I, which SpaceX launched earlier this year, and SpainSat NG II, this launch, will eventually replace the current SpainSat and X-Star satellites. EASTASat is a government satellite operator, providing secure satellite services to government agencies in various countries. EASTASat has provided Earth observation services with radar technology through the PATH satellite, which SpaceX launched on a Falcon 9 back in 2018. SpainSat NG is a part of a program developed by EASTASat to improve secure satellite communications and defense capabilities for the Spanish government and others. SpainSat NG will cover an extensive area that ranges from the United States and South America to the Middle East, Africa, Europe, and Singapore. And we're just now expecting payload deploy in about 1 minute.
Payload deploy confirmed.